Hello and welcome back. Today's session is a continuation of the last one where we deployed a sample application on EKS cluster. So this is what we built. We'll leave a link of that video in the description. And now we are going to add an application load balancer to it in order to load balance the network traffic and access the application itself. So the key thing is that we will not be provisioning the load balancer directly. Instead, we would be creating a Kubernetes ingress, which will take care of creating the load balancer with listeners, target groups, etc. automatically. So this involves a series of prerequisites. So let's get started. Okay, so we are in the AWS console. The first step we are going to do is to tag our public subnets with the tag name kubernetes.io/role/elb. So AWS expects us to tag the public subnets with this tag name so that it can identify that these subnets are available to launch the load balancer. So since we are launching an internet-facing load balancer, we have to tag the public subnets. If you are going for an internal load balancer, then you have to tag the private subnets. And in that case, the tag name is a little bit different. I'll leave them in the description if you're going for the internal load balancer. So we are done with the first step. We have tagged our both public subnets. And the next step is to create an OIDC identity provider for your cluster. So each cluster will come with the OpenID Connect issuer URL. You can find that in the overview section. So you have to copy that and then head to the IAM section. And under that, you will find an identity providers under access management. There you can add a new provider. The provider type is going to be OpenID Connect. So that is the mechanism which AWS uses to verify the clients or the end users. And here you have to specify the provider URL that we just copied. And then click on Get Thumbprint. And then you have to specify the audience. In this case, this is going to be sts.awsamazon.com. Sorry, amazonaws.com. And add the provider. So this will allow us to create IAM roles for our service accounts and access them from our Kubernetes cluster. So that was our second step. And the third step is to create a IAM role for a load balancer. So for that, first we have to create the policy. I have left the policy document in the repository so you can access that load balancer controller policy and then create a new policy. So this gives various access for load with respect to load balancing, like registering targets, creating the load balancer itself and listeners and everything related to load balancer. And you can give the policy a name. I'm going to just call it as load balancer controller policy and create the policy. So once this is created, let's go ahead and create the role for the load balancer. So this is going to be a custom trust policy, and this requires a trust policy document. So that is also available in the GitHub repository. You can copy that. And within this policy, make sure that you're changing the OIDC ID and then the account ID and also the region code. So the OIDC ID can be grabbed from the EKS cluster overview. That is same as the URL that we used, but just the ID part. Have to replace that in 3 places and then the account ID, as well as don't forget to update the region code. In our case, this is going to be US East 1. And once that is done, click on Next. And then select the policy that we just created, which is the load balancer controller policy. And give this role a name. I'm going to call this as load balancer controller role. So this role is generic. Then once you have created the role, the next step is to create the service account within the cluster. So this document is again available in the GitHub repository. So the only thing that you have to change is the role ARN. So this might be different in case you have given a different role name. And then copy the ARN and replace it here. So we have our service account document. Again, I'm going to head back to the command prompt and apply the service account YAML. So kubectl apply -f and then the service account YAML file. So this will provision the service account within our Kubernetes cluster, which will allow Kubernetes to provision the AWS load balancer. Okay, so once that is done, we have a service account in place. The next step is to use Helm and install the load balancer controller within your cluster. So for that, you have to just add the Helm repo first. So Helm repo add and then the EKS charts. That's the repo which we are looking for. And once we have the repo added, you can install the load balancer controller. So this is, again, I'm doing this using Helm, and replace the cluster name within the command. So our cluster name, if you remember from the last session, it was EKS cluster, and the rest can be the same, and execute the command. Okay, so there is a problem. Okay, this is being considered as a line for every line, so I'm just concatenating all the lines and then executing the command again. Hopefully it should go through. So what this will do is it will go and create the load balancer controller within your cluster. So yes, we have it. And then once that is done, finally it's time for us to create the ingress itself. So this is the ingress document. We are going for internet facing load balancer, and we are going to load balancer service 2048, which we provisioned in the last session. So it's the same command kubectl apply, but this time we are going to apply the file ingress.yaml. So this has created the ingress, and you can get the ingress by using kubectl get ingress and then the ingress name, and you have to specify the namespace. So -n and then the namespace which we created in the last session, which is game 2048. So we have our ingress provisioned along with the address associated with this. So this is the address of your load balancer DNS name, and it exposes a service with port 80. And if you do kubectl get all, as in the previous session, we will get all the resources which is associated with that particular namespace. So these were the resources which we created in the last session, which was the pods and then the service and then deployment. Now this service is load balanced using the ingress that we just created. Alright, so now let's go into the AWS console and see the load balancer that we just created. So if you go into load balancer section, you will see the load balancer. It's still being provisioned, but within the load balancer, you should see a listener automatically created. So this listener is going to have only one rule because we are just forwarding all the traffic to the same single service. If your application has multiple services, then you can even pattern match and forward the traffic to different services. So both our pods are connected to the same target group, and it's in healthy status. So we should be able to access our application now. So you can access the application by using the DNS name of the load balancer. So I'm just going to copy this and paste it in a new browser tab. Alright, so we have our application up and running. So it is that simple to set up the ingress for our EKS cluster. So hope you found this useful. If you have any questions related to this, please leave them in the comments below. See you soon in the next video. Thank you.